So states of matter. First of all, let us know what is an ideal gas. We'll be dealing with ideal gas in the whole chapter. This where we'll be seeing that it is basically an hypothetical term. Okay. Okay. So let's start. It is ideal gas. Anybody can tell me what it is? Anybody of you must be knowing. Yes, am I audible?
Yes.
Yes.
Okay, so okay, I'll explain it to you. It is an hypothetical term actually, which is basically based on assumptions. Okay, there are certain assumptions in chemistry which we make, and we consider that gas to be ideal, and then we further make study about it. And in that assumptions, there are certain laws which are given by some scientists, and according to those laws, if a particular gas follows that law, then it is considered to be an ideal gas. So we'll be talking about the laws which we will require to derive our ideal gas equation. First of all, we'll study those laws, and I hope better understanding is possible with this. So let us start with the first law, which is Boyle's law, which was given by Robert Boyle, scientist Robert Boyle. Which okay, let's start with the statement. At constant temperature, the volume of certain amount of gas is inversely proportional to pressure exerted on it. So here, basically, the scientist wants to say that he created a condition in which he kept the temperature constant and number of moles constant. He took a fixed amount of gas, which means that number of moles of the gas he took was constant. And he found out that at this condition, the volume of that gas was inversely proportional to the pressure. And by this, he derived the relation that volume is inversely proportional to pressure. So we get the term as PV equals to constant. So here we will use the constant to remove the proportionality sign, obviously. And we will prove that PV is equals to a constant. Now this derivation, you will be learning about it. There are certain graphs which you will learn. But this is relation, I think it's enough for us to learn about ideal gas equation. So further, we got that PV equals to a constant. Yes, so gas occupying, now we will consider a gas which occupies volume V1 and pressure P1. So we'll get as P1 into V1 equals to a constant according to this law. Now if further, we will keep the temperature constant, and we'll change the pressure to P2. If we'll change the pressure to P2, the volume will change to V2, and we'll get as P2 into V2 equals to a constant. So we can derive by this relation that P1 V1 equals to P2 V2. So this is what Robert Boyle wanted to explain. So I hope this is clear to you. We'll take it fast so that we can complete. Yes, anybody out? Students?
Understood.
No, okay. Okay. So next we'll move on to the second law, which we need here, which is Charles' law. So I'll read out the statement for you. At constant pressure, the volume of fixed mass of gas is directly proportional to its absolute temperature. So in this case, the scientist kept pressure constant, and then and also number of moles will be constant here also. Again, we'll take a fixed amount of gas. So in that case, he that volume is directly proportional to the temperature. Absolute temperature is, but it is under the standard conditions which the scientist used to consider. So volume is directly proportional to temperature. So we'll get as V upon T equals to a constant again here. So as previously we found that P1 V1 equals to P2 V2. Here we'll get as V1 upon T1 equals to V2 upon T2. Yes, I hope this is clear.
Yes.
Okay, got it. So the third law, you'll get a better explanation of this whenever you will be learning. So Avogadro's law, third law which we need is, it states that equal volumes of all gases under the same conditions of temperature and pressure contain equal number of molecules. So here, what the scientist wanted to say that he kept the temperature and pressure conditions constant. ओके, इथं टेम्परेचर आणि प्रेशर कॉन्स्टंट ठेवलं. प्रिव्हियस म्हणजे प्रत्येक कंडिशन मध्ये एक अशी कंडिशन क्रिएट केली होती जिथे एक कुठली तरी टर्म होती जी कॉन्स्टंट ठेवली होती, राईट. सो हिअर वी हॅव केप्ट टेम्परेचर and constant. This relation wanted to prove that volume of that gas is directly proportional to the number of moles. Okay, so by that relation v upon n equals to a constant. So again here v1 upon n1 will be a constant. So you can maybe you will get very easy numericals on this. And by these terms, why we are taking these laws, because by these terms we'll derive our ideal gas equation. Okay, so here we'll come to the main point, and now I hope you'll understand it better. My friend will continue.
So, ideal gas equation. We've learned the three laws: Boyle's law, Charles' law, and Avogadro's law. So, according to Boyle's law, we get that by keeping temperature and number of moles constant, we get the condition volume is inversely proportional to pressure. Similarly, by Charles' law, we get volume is directly proportional to temperature by keeping pressure and number of moles constant. And by Avogadro's law, we get volume is directly proportional to number of moles by keeping pressure and temperature constant. So from that, we get an equation. Now here volume is proportional to temperature as well as number of moles as well as 1 by pressure. So we get the equation volume is directly proportional to N into T into 1 by P. So by removing proportionality symbol, we get a constant here R, that is universal gas constant. We can also call it proportionality constant. So from here we get the main equation, that is PV is equal to nRT. This is the main equation in ideal gas, where P is the pressure of gas, V is the volume of gas, N is number of moles of gas, R is the universal gas constant, and temperature P. That's absolute temperature. Now, standard temperature and pressure. This is the standard condition that is maintained. So, temperature, that is absolute temperature, the term I mentioned earlier, it is 273.15 Kelvin. This is called as absolute temperature. Standard pressure is 1 bar, that is 10 raised to 5 Pascal. And by keeping temperature and pressure values, we get molar volume, that is 22.71098 liter per mole. So these are the standard values which we can use. Now from these values we can find the value of universal gas constant, proportionality constant that we used earlier. So by equation PV is equal to nRT, we get this as R is equal to PV upon NT. And now by keeping the standard values, we get different values according to the different units that we have to use in for the numericals. Here, this value is for moles, so number of moles is 1 mole. Temperature is 273.15 Kelvin, that I mentioned earlier. Pressure we've taken as 10 raised to 5 Pascal, and volume as 22.71 into 10 raised to 3, as we have converted into meter cube. So by keeping these values, we get it as 8.314 Pascal meter cube per Kelvin per mole. So have you understood?
Yes.
Yes, understood.
Yes, so basically we reach to the value of R here, right? So R is the universal gas constant, and here the units you can remember from PV upon NT relation. So you'll get how it will be the better way to remember the units in this case. So I think these are some values, and these values you can use according to the question. The values that will be given in the question, you will use according to that. So next, yes, this one thing you should know: ideal gas equation is also known as equation of state. So because it depends on certain assumptions which we make. So okay, here's a question for you. I hope everybody is clear with the equation, the laws. Yes?
Yes.
Yes.
समजलंय सगळ्यांना?
हो समजलं.
Okay. So, can anybody read the question for me? Yes?
I'll read.
Okay, read.
The pressure of the atmosphere is 2 into 10 raised to minus 6 millimeter at about 100 mile.
1 second. It's mm of Hg actually, not millimeter.
Okay. Atmosphere is 2 into 10 raised to minus 6 mm of Hg at about 100 mile from the earth, and temperature is minus 180 degrees Celsius. How many moles are there in 1 milliliter gas?
Yes. So they have given you the pressure, right? So pressure is in terms of mm of Hg. They have given you the temperature. So what were the terms which we discussed all through? Yes, can anybody once tell me? All the terms which we mentioned from in all the laws which we studied.
Pressure, temperature,
Yes.
Volume, number of moles.
number of moles,
Yes, and obviously universal gas constant
Universal gas
also.
constant R.
Don't forget.
R.
This is a new thing maybe for you. So yes, here are the given values. Again, we'll convert them according to the question as if they have given it into mm of Hg. So we'll make it into atm, right? Atmosphere pressure. So for that we need to divide it by 760. And again, temperature is given in degrees Celsius. So everybody knows this conversion, right? We'll add 273 to degrees Celsius and then you'll get the value in Kelvin. Yes?
Yes.
Yes.
Converted into liter. So yes, can anybody try this? Everybody try it once. Obviously, you're given all the values, and here you have to find the number of moles. And here I'll tell you the value of R which you will be using is 0.0821. Yes, I'll tell you the value of R also. 0.0821. It's a very easy question, just calculations. Yes. Anybody? Yes. Anybody?
Which equation should we use here?
Yes, tell the equation which we derived.
PV is equal to nRT.
Yeah.
Yes, correct. PV equals to nRT. So you have to use that same equation here. Okay.
And just
So,
keep the values.
and you have got all the values. Yes, you got the value of R 0.0821. Yes, everybody. Am I audible?
Yes.
Yes.
Okay. Okay. So can you solve it now?
Yes.
Okay. Try it on your side. You have understood, everybody, what you have to do? Yes, everyone.
Yes, understood.
Okay.
Have you got the answer?
Anybody? You have to keep the values PV in PV equals to nRT, from where you will get the value of n.
Or should we show the solution?
Anybody? Okay, should we show the solution? Has everybody understood what you have to do? Yes? Are we audible,
Yes,
students?
understood.
Okay. So you're trying? Everyone?
Yes.
Okay. One more minute.
Is the answer 0.34?
Okay, and into, yes, 10 to the power something, right?
Oh, yes.
-11.
Hey, anyone having doubt, you can ask,
Yes,
okay?
you can ask. If you have not understood, you can ask once again.
But you have time limit of 10 minutes, okay? So I think you have finished the time limit. Sital Gaikwad, be ready, okay? तुमचा टाइम लिमिट संपलेला आहे.
Okay, sir. We'll display the solution for you. Yes,
Paper
your
two.
answer was correct. Yes. Okay. Anybody wants to say something?
Understood.
Okay. So this is the answer. I hope you have reached till there.
Yes.
Okay. So thank you for cooperating with us, everybody. Thank you, sir.